Should be going. Okay. We are on section 4. Let's see if we can resurrect some things we learned before break a long, long time ago. One of the goals, it is recording, one of the goals we've been working towards, you can see the red barely around the edge. I'm recording a larger area because we're going to go to graphing software a little bit. One of our goals has been trying to take these polynomials and factor them or figure out what makes them equal 0. And those are kind of synonymous things. We use one to accomplish the other. The fundamental theorem of algebra says if I have a polynomial of degree n, as long as it's greater than or equal to 1, first degree, second degree, etc., and it has complex coefficients. Now, when we say complex coefficients, it means we don't just have to have integers there. We can even have imaginary or complex coefficients. Then it's going to have at least one complex 0. So we should be able to find, if I have a first degree or higher, I should be able to find a 0 there. The next idea, linear factor theorem, builds upon this one right up here. And it says if I have a polynomial function of degree n, again, first degree or greater, then that polynomial, they've just given an example of a polynomial where they don't put any numbers, then it has exactly n linear factors. So that means if it's a second degree, I can factor it into 2 factors. We knew that. We did that all the time. Third degree, 3 factors. Fourth degree, 4 factors. You get the idea. So the number of zeros, which simply means each factor set it equal to 0. If I have a polynomial and I want to know what makes it equal to 0, x plus 2, x minus 7. Oh, if I can make 2 factors, 2 linear factors, it must have been a second degree equation. And this leads to how many zeros did I get here? 2 zeros. So we are going to have, as long as we count multiplicity, the same number of zeros as the degree of the polynomial. Remember what we mean by multiplicity? Let's say it factored as x plus 2 squared. Well, then x equals negative 2 is the only 0, but we count it twice because it has a multiplicity of 2. So we call it a double 0. Now, let's pull up. We're going to be using software. And we're even going to be going across the hall to do some work today. Let's see if I can find this. I already had it pulled up. We're going to be using Desmos here to help us do some things. Now let's come back over here. We're supposed to find the zeros and the linear factors of these polynomial. We want to find all the zeros of these things and then write it as a product of the lead coefficient and its linear factors. We'll see what that means as we go along. Well, as I look at this polynomial, we know that we can start out trying to figure out zeros by doing this rational zero theorem test. Factors of 16, so plus or minus 1, 2, 4, dot, 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 over q factors of lead coefficient, which is 1, which is just plus or minus 1. And then we can start down the line if we want to, trying to figure out where our first 0 is. We even have a Descartes rule of signs. Remember positives and negatives? Let's count this one real quick. How many sign changes, which will tell me how many possible positive? We've got 1, 2, 3, 4. So we have 4 or 2 or 0, positive possible ones, etc. We're going to take a little bit of a shortcut, which is graphing these to figure out the zeros or where they equal 0. So I happen to have example number 1 written here. And if we graph example 1, we notice that it crosses the x-axis where? At 2. Now we notice something else. It doesn't really cross the x-axis, it just touches. What does that tell us about that 2? It's an even. It's either squared or maybe it's a 4th power. I know 2 is a 0. So I'm going to use that information back over here. And we are going to do our synthetic division. We know it should equal a 0. So let's see. 1, Negative 4, I'm not missing any powers, am I? No. Negative 4, 8, negative 16, and 16. Bring down to 1, 2 times 1 is 2, add them together, multiply, add them together, multiply, add them together, multiply, add them together. Sure enough, it worked. Now I'm going to choose 2 again. And I'm going to choose it on this thing right over here. Since I saw from my graph, it must be an even power, and I'm using this reduced polynomial. So bring down the 1, reduced polynomial, this one right here. So 2 times 1 is 2, that's a 0, that's a 0, that's a 4. 2 times 4 is 8. Ah, there's another 0. It worked again, just like we expected it would. Now, let's go back up here. We started with a 4th degree. That means this one is a 3rd degree. This is a 2nd degree. Let's not keep going with that. Let's change it back into its polynomial. 1x squared, 0x, plus 4. Where does this equal 0? Ah, well, let's solve it. X squared equals a negative 4. How do I get rid of the square and just add the x? Plus or minus, I'm sure I heard, square root of negative 4, which is plus or minus. How do I take the square root of negative 4? 2i. 2i. How many answers do I have right there? 2 of them. To go with these 2 up here for a total of how many? 4 on my 4th degree. So, first thing they said is find all the zeros. So let's list our zeros. My zeros are plus or minus, whoops, it wasn't plus or minus 2. I had 2. Now it occurred twice. And plus or minus 2i. Then they said write it as a product of all its factors. Well, if 2 is a factor, x minus 2. And it occurred twice, right? Squared. And then positive 2i is a factor, x minus 2i. And negative 2i is a factor, x minus a negative plus 2i. There's the polynomial written as a product of its linear factors. If you multiplied it all together again, you would just be back to where you started. So let's go through these steps. What do we do on this? The first thing we're going to do is we're going to look at the graph of this to get us started. So, once again, miraculously, I happen to have that written down. So we look at the graph of it, and we discover, hey, there's a couple of zeros. What are they? Negative 3 and 1/2. Well, we won't be bothered by either integers or fractions. I'm going to start with that negative 3. And I'm going to do synthetic division. It should give me a 0. I have a 2, a 1, a 39, a 136, a negative 78. So bring down the 2, that's negative 6, that's negative 5, that's positive 15. What is that, Nick? 54. Negative 3 times 54, 162. Negative 162. Oh my. 26? Negative 26? Negative 3 times this is a positive 78. It worked. Negative 3 was a 0. We also saw, what was the other number? 1/2 should work. 1/2, we're going to take that reduced polynomial, the 2, the negative 5, the 54, the negative 26. Bring down the 2. 1/2 times 2 is 1. Add them together, negative 4. 1/2 times negative 4 is negative 2. Add them together, 52. 1/2 of 52. Aha, it worked just like we expected. Let's see. We started with the 4th degree, so there's a 3rd degree. There's a 2nd degree. 2x squared minus 4x plus 52. What are we going to do to figure out where this equals 0? Let's factor out a 2. 2x squared minus 2x plus 26. And now it's like, oh, I might be able to factor that. Shall we try it? Multiply to be 26, add up to be negative 2. Let's not spend too much time. Well, it was a good idea. You're not going to get integers that are going to work on that one. So what can I do now? Quadratic formula. Now let's just do it on the part here that's factored, the x squared minus 2x plus 26. So negative b, 2, plus or minus the square root, b squared, negative 2 squared is 4, minus 4 times a, which is 1, times c, which is a 26, all divided by 2 times a, 2 times 1 is 2. So 2 plus or minus the square root of, what's 4 times 26? 104, right? 4 minus 104 is a negative 100. Double check my math. Okay, I'm going to split this apart. 2 divided by 2 plus or minus, what's the square root of negative 100? 10i divided by a 2. 2 divided by 2 is 1. 1 plus or minus 5i. There are 2 zeros to go with these 2 zeros up here, making my total list of zeros negative 3, 1/2, 1 plus or minus 5i. So there are all my zeros. Now they want the factors. Come back up here. Okay, now they want the factors. Give myself a little more room. Well, negative 3 was a factor, so what is it? X plus 3. Was it a negative 3 or a positive 3? It was a negative 3. X plus 3. 1/2 was a factor, so x minus 1/2. Now notice every time we write these, it's always the negative of the number, or the opposite of the number, right? So let's keep that in mind when we come over here to the 1 plus 5i. X, if I do the negative of the top part, the plus part, that's a negative 1, negative 5i. Still didn't give myself enough room. And if I do the bottom part, the negative of the bottom part is x minus 1 plus 5i. Now we're going to do one more thing. We don't like a 1/2 right there. Why? I don't know. But we just don't like it. So, if I remember, I forgot something up here. If I remember, what was the lead coefficient of this thing? I still need that 2 because guess what? I factored it out there. We need to keep it. I can't lose it. So that 2 still needs to be out here. There's still a 2 right here. So what we're going to do, double check your book. Let me see if they do it, because I may be off on what pre-calc does, and your college algebra may not do it. Do they leave the 1/2 there or not? This is example number 1. Do they leave it? Okay, all right. We'll leave it. I have a 2, and the order we write it doesn't matter. I don't know if they have the 3 or the 1/2, but anyhow. X plus 3, x minus 1/2, x minus 1 minus 5i, x minus 1 plus 5i. There's my function written all out as a product of linear factors. Conjugate pair theorem says if one of your zeros is a complex zero in the form of a plus bi, you know it will have an a minus bi as well. Let's back up here. Notice we had a 1 plus 5i. What else did we have? A 1 minus 5i. They always occur in pairs, conjugate pairs. It just means one time we're adding, the other time we're subtracting. Back here we actually do 2. This could be written as 0 plus 2i, 0 minus 2i. Anytime you have a complex zero, they always occur in pairs. There's always 2 of them, anytime you have it. So if we keep that in mind, let's try this. Find all zeros of this polynomial, given that 2 plus I is one of the zeros. So instead of going to a graph like we did back here to get our first numbers to start with, they're telling us, oh, here's one of the zeros. All right. When I knew a zero, we did synthetic division, right? I wonder if I can do synthetic division with complex numbers. Well, of course. Just have big pieces of paper available. 1 minus 4, 14, minus 36, 45. It's the same rule. I bring down my 1. What's 2 plus I times 1? 2 plus I. Now I need to add these together. Well, I can only add the real parts together. Negative 4 and 2 make 2. 0 plus I is I. Now I need to multiply. Negative 2, thank you. Now I need to multiply 2 plus I times negative 2 plus I. So what I do, you'll have more room. I do it over here. 2 plus I times negative 2 plus I. I need to multiply these together so I can figure out what I write under that 14. Well, first terms is negative 4. Outside is 2I. Inside is negative 2I. That's gone. Last terms are plus I squared. Well, what's an I squared? Negative 1. So what's negative 4 minus 1? Negative 5. When I multiply those together, I get a negative 5. Okay, 14 minus 5, 9. Multiply here, well, that'd be 18 plus 9i. If I multiplied those together, put it over here. Now I need to add these together. Well, negative 36 plus 18, that's negative 18 plus 9i. I need to multiply these together. Well, let's do it over here again. 2 plus I, and what was it, a negative 18? Negative 18 plus 9i. You want to be careful. I hope I don't make a mistake early on, because then I have to redo a whole bunch. First terms, negative 36. Outside is 18i. Inside is negative 18i. Gone. Last terms are plus 9i squared. Well, that really becomes a what there? Minus 9. So what's negative 36 minus 9? Negative 45. Ah! 0, just like it was supposed to be. So here is one of my zeros. Tell me another 0 if 2 plus I is one of them. 2 minus I. So now I need to take 2 minus I into the reduced polynomial, this thing, 1, negative 2 plus I, 9, negative 18 plus 9i. Need to divide into that. This actually is easier than the first one. Watch what happens. This is so cool. Bring down my 1. Multiply by 1, I get 2 minus I. Add those together. What do you get? 0. And when I multiply by 0, I get 0. 9 plus 0 is called 9. Multiply this by 9. That's easy to do. 18 minus 9i. Ah, what do you get when you add those two together? Better get 0, or we made a mistake somewhere. There's another one. Now we started with the 4th degree. There's a 3rd degree. There's my 2nd degree. 1x squared plus 9 equals 0. I'm going to subtract my 9. I'm going to take plus or minus square root of my negative 9, which is plus or minus 3i. I have 2, 3, 4 zeros. How many of those are real? None of them. Which means if I looked at a graph of example 2, tell me what it means. Oh, I don't even have it there. What it means is it never crosses the x-axis is what it means. I don't have any x-intercepts. A graph would have done us absolutely no good on this one. It would tell us they're all complex. So they have to start us out somewhere. They say, find all the zeros. There are all the zeros. I'll go ahead and write them out. My zeros are 2 plus or minus I and plus or minus 3i. What's that?
How would you figure out the zeros had they not got? I'm thinking.
Let me think a minute, the answer to that question. I don't know a technique to do it with a complex. That's a very good question. I can't think of a technique. We'll move on to here as I try to think of a technique. Apply the conjugate pair theorem. We just applied it a little bit ago. Again, they say find all zeros of this polynomial given that this is one of the zeros. Now the real exciting part is, what degree is this? We've moved up from 4th degrees now. We're up to 5th degrees. Now we know how to do this. 3, and we do this very carefully because we don't want to mess up early on. Let's see. 1, negative 10, 65, negative 184, 274, and negative 204. They don't leave me very much room over here to do some work. Bring down my 1, multiply by 1, that's 3 minus 5i, so I get negative 7 minus 5i. Need to multiply those together. Now this one is going to be a little bit more fun than the last one. 3 minus 5i, what was it, negative 7 minus 5i? The last one had lots of things that just canceled for us. Well, my first terms would be negative 21. My outside are negative 15i, and the inside is positive 35i. What's negative 15 plus 35? 20. Plus 20. And my last terms, I have plus 25i squared. Since I squared is a negative 1, that number on the end is really negative 25. So what's a negative 21 minus 25 more? Negative 46 plus 20i. So there's my answer. When I multiplied these together, I got a negative 46 plus 20i. I can add them together. What's 65 minus 46? We don't want to get it wrong. How much? 19 plus 20i. Now I need to multiply these together. So we have a 3 minus 5i times 19, what was it, plus 20i? Plus 20i. So 3 times 19, how much is that? 57. Outside is 60i. Oh, negative 5 times 19. What's that?
95.
So I have 60 minus 95. Negative 35i. Negative 35i. Now my last term, so that'd be a negative 100i squared, which really is the number positive 100. So 57 plus that 100 gives me 157 minus 35i. You can handle it. I multiply these together, I get 157 plus 35i. Now I need to add these. What's negative 84 plus 157? Say that again.
Wasn't it minus 35i?
Yeah.
Thank you. Minus 35i. Negative, what'd you say? 27 minus 35i. So I need to multiply these together. So, I have a little more room here. What was it? 3 minus 5i. 3 minus 5i times negative 27 minus 35i. Well, 3 times negative 27, that's negative 81. Outside, 3, that's negative 105. Oh, I don't know, what's 5 times 27? 135? 135 minus 105. 30. 30i. Last terms. Did I do this right? Okay, yeah. What's 5 times 35? I hope so too. Positive 175i squared plus 175i squared. So we know that's really minus 175. What's negative 81 minus 175? Negative 256 plus 30i. Negative 256 plus 30i. 274 minus 256.
Mr. Jones, he's fair.
Okay. 274 minus 256.
18.
18 plus 30i. So here we go, once more. 3 minus 5i. What is it, 18 plus 30i? 3 times 18, how much? 54. Let's see, that'd be a 90. What's 5 times 18? 90. 90i minus 90i, ooh, they're gone. Last terms. Negative 150i squared, which really means plus 150. So what does that give me? So I multiplied those two together and I got 204. That's a 0. Now what do I need to do? This one is always easier. 3 plus 5i, and it really is. It's not going to be quite as simple as the last one where we had zeros a whole bunch of times. 1, negative 7 minus 5i, but it really is going to be nice. 19 plus 20i. This is called college algebra, not algebra 2, remember. 35i. 18 plus 30i. So I bring down my 1, I multiply by 1, 3 plus 5i. Notice what cancels? The i's. Negative 7 and 3 make a negative 4. Now that would be negative 12 minus 20i. Negative 12 minus 20i. Do you notice what cancels? Every time, if we do it right, those i's will cancel. What's 19 minus 12? 7. 21 plus 35i. We know we're on the right track because our i's keep canceling. Negative 27 and 21? Negative 6. So multiply here. Negative 18 minus 30i. Woo! All right. So we've gotten this far. Now where did we start up here? 5th degree. So that's a 4th degree. That's a 3rd degree. We have x squared minus 4x plus, whoops, 3rd degree, x cubed minus 4x squared plus 7x minus 6. We're trying to figure out where that equals 0. I can go to a graph on this one. So we graph in, and I may have done the original one. I don't remember. Oh, I did the original one even. But it will have the same 0. 2. 2 works. So let's try 2 on this. Right. You still have to have the complex. You still have to do that, even if you started with the 2. Because when you started with a 2, you would still be at a 4th degree. And then we have complex. They have to give us one of those. All right, negative 4, 7, negative 6. So we bring down our 1, there's a 2, there's a negative 2, there's a negative 4, there's 3, there's 6, there's 0. So we're happy about that. And this is x squared minus 2x plus 3. Does this one factor? Multiply to be 3, add up to be negative 2. What is it? So what are we going to do? Quadratic. So let's see, negative b, 2 plus or minus square root b squared, that'd be 4, minus 4 times a, which is 1, times c, which is 3. 2 times 1 is 2, so we get 2 plus or minus 4 minus 12. Negative 8, right? All divided by 2, so we're going to separate and simplify. We have a 2 over a 2 plus or minus. What perfect square goes into that? 8? 4. So it's 2 squared roots of 2. I over the 2. 1 plus or minus square root of 2i. Square root of 2i. More complex. 2 there, 3 here, 4, 5 there. Whew, for our 5th degree. Find all zeros. Our zeros are, what was it? 3 plus or minus 5i. There's a conjugate pair. 1 plus or minus square root of 2i. And our one lonely rational 0, 2. That's the only one that would show up. That's right. Wow, this is fun. I hope we have lots and lots of these. Solve this one. Well, you tell me. How do I start? We want to solve. Where does it equal 0? How do I start? Let's look at a graph. So we look at our graph, we pull up our graph, and we discover that 3 is an x-intercept. Tell me about that 3. More than once. Multiplicity of 2, 4, I don't know. Maybe they're all 3s. Could we be only so lucky, huh? So we know 3 is going to work. 1, negative 5, 4, 3, 9. So 1, that's 3, negative 2, negative 6, negative 2, negative 6, negative 3, negative 9. There's 1, 0. We know 3 should work again. Can you handle it if I do this? Instead of rewriting that all over again, I'm just going to use that one. Now we've chopped off the 0. Bring down the 1. That's a 3, so there is a 1, there's a 3, so there's a 1, there's a 3, so there's another 0. Oh, 3 worked again. Well, we started a 4th, so there's a 3rd, there's a 2nd, x squared plus x plus 1 equals 0. You're going to have to go to the quadratic formula. That one's not going to factor. Negative b, negative 1 plus or minus the square root of b squared. 1 squared is 1 minus 4 times 1 times 1 all over 1. Oh, 2a. 2. Better make it a 2. What's 1 minus 4? Negative 3. Negative 1 plus or minus the square root of negative 3 all over 2. So it's negative 1/2 plus or minus.
X squared 3i.
What do they want us to do? Solve this? What are the solutions to this? When x equals 3, and when x equals negative 1/2 plus or minus the square root of 3 over 2i. There are answers to it. We're doing the same thing over and over again is what's going on here. The very last one. For each polynomial function, we need to change it up, do something more interesting now. For each polynomial function, find a polynomial of 3rd degree that happens to have 1, 2, and negative 3 as zeros.
Go back.
We're going backwards is exactly what we're doing. Tell me the factors.
X minus 1, x minus 2.
Now I want to find a polynomial not in its factored form. I'm just multiplying it together. Let's use FOIL right over there. First terms, x squared, outside negative 2x, inside negative 1x, so that'd be negative 3x. Last terms plus 2, so those are the first two. I'm going to distribute. I'm going to go right to left is how I'm going to distribute. So I'm going to start with the x and multiply everything here by x. X cubed minus 3x squared plus 2x. Then my 3, multiply everything by 3. Plus 3x squared minus 9x plus 6. And then all I have to do is get my like terms together. X cubed. Hey, x squareds are gone, aren't they? 2 minus 9, negative 7x plus 6. There's the polynomial that would have these zeros. That's easier. Just backwards. So that was a little too easy, wasn't it? We want a 4th degree. 2i is a 0 and 3 minus 7i is a 0. Now wait a minute. If it's a 4th degree, there should be 4 zeros out there. So if 2i is a 0, negative 2i is a 0. If 3 minus 7i is a 0, 3 plus 7i is a 0. So when I go to write my factored form, let's see, x minus 2i, x minus a minus, x plus 2i, minus this top one, x minus 3 plus 7i, both signs would change, minus the bottom one, x minus 3 minus 7i. Well, there I have it factored form. Now, when you multiply them in these two groups. It's going to be much easier if you do it this way. So let's start with these two here. First term's x squared. Outside is a plus 2ix. Inside minus 2ix. It cancels. Last term's minus 4i squared. Minus 4i squared. We'll come back and simplify that. Let's move on to this one. Now, how do I multiply a trinomial times a trinomial? I distribute. We need to distribute the x times all 3 of those. So if I distributed x, I would get x squared minus 3x minus 7ix. then I need to multiply negative 3 times all three of those. Negative 3x plus 9 plus 21i. Multiplying everything by negative 3. Now I need to multiply everything by a 7i. Plus 7ix minus 21i minus 49i squared. Well, let's come back here. What's a negative 4i squared? Plus 4, right? X squared plus 4. Now, as I look at the second one, I'm going to look for some like terms. I only see one x squared. I see a negative 3x and a negative 3x, which would make negative 6x. So I've taken care, well, I'm just going to work my way down the line. Negative 7ix. What else do you see? A plus 7ix. They just canceled out. Let's see, we already did the 3x, didn't we? I see a 9. Oh, we better go down here. What's a negative 49i squared? That's plus 49. What's 9 plus 49? 58. Now, what else did we have? Oh, 21i and a minus 21i. Notice at this step, all the complex and imaginary ones are gone. Now we're closer. I still need to multiply. I need to distribute. I need to distribute the x squared times all three of these. So x to the fourth, multiplying it here, minus 6x cubed plus 58x squared. Now we need to take that 4, multiply everything by 4, plus 4x squared minus 24x plus, oh my. Let's see, 232, is that right? 232. Now I look for any like terms, and I have this beautiful function, x to the fourth minus 6x cubed. What do we have in our squareds? Plus 62x squared? Minus 24x? Minus 24x plus 232. And that's the polynomial that had those lovely zeros that they started with us at the beginning. Your turn for fun. Now, my question to you, I guess,